in this lecture some hints on how to solve problems in the homework using R and using your probability skills that you learn in the course. So here's the first question that I want to ask you. So let's say there's a cricketer called Veda. She can hit the stumps 70% of the time when she throws at the stumps from a certain position in the field. Let's say she attempts in practice 10 throws. Now what I'm asking the question is, what is the chance that she will hit the stumps 7 times out of 10? That's the question. Okay. And the chance that hits the stumps in each throw is 70%. Okay. So how does one solve this problem? So here's the solution. Let me use a different color so it's clear. So solution. So the way one would do this is that you'd think that hitting the throw with 70%, hitting the stumps with a throw is success. So you could think of P as the probability of success as, let me use blue for the correct link. So P is the probability that a stumps will be hit. The probability that the stumps will be hit. And this probability in the question is given to be 0.7, right? So we just move it across here, and this is going to be equal to 0.7, right? And then Veda attempts how many throws? 10 throws, right? So the number of trials, n, is the number of throws, that Veda makes is equal to 10. That is, the number of throws is 10. Then let me make it everything in the same sort of format. So 10 is right here, so the number of throws, and let me put 3 lines here, so it's the definition, right? 10. Then what do you want? You want to know, the question is that Veda hits the throws 7 times, hits the stumps in throw. So let's say K is the number of hits to the stump in these 10 throws is we want to know 7, right? So the way we would model this thing is that P is the probability of success, n is the number of trials, and you want 7 successes in 10 trials, right? So you can model it by the binomial experiment. So the probability that Veda hits the stump 7 times in 10 throws is equal to what now? So that means you have to choose the 7 throws, that is where you hit this 10 choose 7, right? And then in 7 of them you should hit the stumps. That means the chance of success is 0.7, that is 0.7 to the power 7. And then the rest you should not hit the stumps because you want exactly 7 hits. So it's 1 minus 0.7 to the power, this is 10 minus 7, right? And there are 3 throws. So it's going to be equal to 10 choose 7, 0.7 to the 7, and then 0.3 to the 3. Now once you have this, you'll think that, okay, fine, how do I do this? Because the question, if I want to write like a fraction, if I want to write this as, this is equal to something like something divided by something, like 1 by 2, if I want to write like this as a fraction, how do I do this? So one way to do it is you can do it by hand, you can play with it. But the other way is we can use R to do this. So let's go to R. Sorry, where is R now? R is here. So go to R. So the first thing I will do is I will write out the expression. So the expression is choose 10 and 7, right? Star, what do I have? I have 0.7 to the 7, right? And I multiply again by 0.3 to the 3, right? That's what I have. So once I do this, I press enter and I get a number. So it's 0.268. Of course, this is a very long fraction. If you want to convert it to a long decimal, convert a fraction, you have to multiply it by maybe a million and then divide by a million and so on and so forth. But we will not do that. What we will do is we will use the mass package in R. So library MASS is the mass package in R. We'll use that, right? Then what I'll do is I will call the previous one and I will call it as X. So I'll say x is equal to this. That's the answer. Or let's say the answer is equal to this, right? That's that. Sorry, answer. I don't know. Answer is coming. Answer is equal to this. So then what I want to do is I want to convert the answer into a fraction. So what I'll do is fraction answer is equal to what you can use. You can use the fraction command in mass. It's called fraction. Then ans. You enter it. It'll give you and press enter. Some errors there. What error did I make? Interesting. I do not know. Let's see. Oh, it's called fractions. I'm sorry. Fractions. That's the command. That's this. And then I go and put fraction ans with the fraction answer. So what do I get? I get 1080810 and 40513. So I go to my file again, and the answer would be, let me go back to R. R says 10810 at the top. So I put 10810 at the top, and I go back, I get 40513. So I get divided by 40513. So that will be the answer. Very nice. So that's the chance that Veda makes seven hits to the stump in 10 attempted throws. Now let's proceed to the next question along similar lines. So let's say Sehwag comes in, and he's not that good a fielder as Veda. He hits the stumps only 40% of the time. Okay. Then what Veda does is Veda says, okay, let's play a game. So Veda and Sehwag play a game where the first one to hit the stumps is the winner. Okay. So Sehwag is not as good. He's only 40% stump hitter. Veda is 70%. So Sehwag goes first. So whoever hits the stump first is wins. So what's the chance that Sehwag will win the game on his first shot? Let's think a little bit. What's it going to be? That means he goes first. He throws the ball. The chance of hitting. So here what happens? Here again you do the same thing. Here let's say P, right, is the probability that Sehwag hits the stump in one throw. Right, that's equal to 0.4. Right, and so if you want to win the game in the first shot, then he has to hit n is equal to 1. So here n is equal to 1, and you want k is equal to 1. Right, so n is equal to 1 throw, and k is equal to 1 hit. So the probability, the answer is going to be equal to what now? The answer is going to be equal to, it's a binomial experiment, but only one trial, so it's a Bernoulli trial. So chance is just P. So answer is just 0.4. Because he has to make the shot. So it's 1 choose 1 times 0.4. That's just 0.4. And that if you want to convert to fractions, you do it like 4 by 10. This you can do by hand. And that's the same as 2 by 5. Very good. Very nice. The next question is the same thing. What is the probability Veda will win this in her first shot? So here you have to be a little bit careful. So here what happens is first Sehwag throws, right? And Veda will get a chance only if he does not hit the stumps, right? And does not hit the stump. Right? And the next throw, Veda throws and hits the stumps. Veda throws and hits the stump. So that's the scenario you're talking about, right? And these two events are independent. So the probability of this happening, the probability of Sehwag throwing not hitting the stump, and the next one, Veda throwing and hitting the stump. Let me put this as and, so it's not, no confusion is there. Sorry about that. And Veda hits the stumps. This is going to be equal to what now? This is going to be equal to 0.6 is the first person that's independent. So we'll write it in the first thing in proper fashion. So I'll write this as probability that this happens is equal to the probability that, let me try to see if I can cut and paste properly right now. Let me get this across. Sehwag this, and I close the bracket because the independent events, this times the probability that Veda wins the next one, right? That's by independence of the two things, right? So once you have this, then you know that this is equal to 0.6 times, because 0.6 is the chance that he does not make the throw, right? Because 0.4 is the success probability that we have here. 0.6 is the chance that he does not make the throw, and Veda's hits its 0.7, and that's going to be equal to 0.42. If you want it in fractions, it's the same as 42 by 100. And this you can do by hand. It is 21 by 50. Okay. That's all I wanted to sort of share with you today to see if you can do this thing.